Welcome students. In this module we are going to learn about functions. The understanding of the function mechanism is very essential to a C programmer, because in any real world program we divide our program into several modules or several functions. Now, how do we divide a program into several tasks or modules which we call as functions? Each function will actually carry out a certain well defined task, because in real world the programs are usually large and we don't want to write everything in one place. We want to divide the program into several well defined tasks which we call as functions. And I think all of us are already familiar with the notion of a function, a mathematical function. We know that every function, for example, if you take a square function, for example, if you give the input as 5, you get the output as 25. You give the input as 6, you get the output as 36, so on and so forth. We know that we call this part as the domain and this is the range. So the basic characteristic of a mathematical function is that the output is only one for any given input or inputs. You will always get a single output. So that is the reason why the designers of C have called these modules or program modules as functions, because what you have to remember about a function is the fact that however or no matter how many inputs you give to a function, you will always get a single output. So that's the reason why the creators of the C programming language have named their program modules as functions. Now let us take a very simple example to learn the function mechanism, so that it will help us to become better C programmers. Now let us take the task of adding two numbers, which is very fundamental, which is very simple. In order not to get distracted by other details, we will take that simple program, and using which let us try to understand all the fundamental issues about the function mechanism. Let us begin to write the program. now you can see the program which has been written using a function which you have named it as add. I just want you to have a closer look at the program now, which you have already written without using a function. Now we are doing it using a function. First thing I want you to notice is the line here. That line is known as the function prototype. Or sometimes known as function declaration. It is referred to either as function prototype or as function declaration. Then let us look at what it actually says. As you can see here, there are several different parts in it. This is ADD, is what we call as the function name. You can give it any appropriate name as you please as a programmer. It is an identifier name. I just chose to call it add because the function is written in order to add two values. So I just named it add. You could have called it sum also. It doesn't make any difference. So first thing is you have to name it because you are going to call it later. So we name it. So this is the name, and in brackets, parenthesis, we can see that there are two different integer variables which have been declared. I call them as int space a comma int space b. So we are actually declaring two variables a and b. Now whatever is given inside these brackets will be treated as inputs to this function. We call them as arguments. And finally we see here again another int that is actually known as the return type. So what exactly is a return type is nothing but when you call this function, this tells you what is the data type of the value that is sent back. So name of the function, in brackets the inputs to the function. Here in this particular case there are two inputs to this function, and what does the function return back. So it is like, which is here in this particular case is the data type int. So this in essence captures the behavior of the function. Name is given, what are the inputs to be given to the function when it is called, that is also given within brackets, and upon returning what is the value it actually returns. So this is, please note the semicolon here in the function prototype. So this is one part of this function mechanism. Now let us see what happens. Let us, all of us know that the C program always it begins to execute with the main function. So here is one main function is there. First let us see the organization of this program. Main function is beginning here and ending here, and after that we have written the add function. Actually that comes after that because it's the board, we have written it there. And in every C program the function or the execution begins with the main function. So let us see. Begin with three variables are declared, and in the main function it is asking for two values. The user types in the two values. Let us say that this is the variable a and this is the variable b. We will draw the line here so that we separate the main function and the add function. This is b. Now let us say the user has typed in the values 3 and 6 respectively for a and b. So that is until this point. So when the program executes until this point, that is the situation. Now I want you to notice again this line here which is new. We can see add within brackets a comma b. There is no int or anything like that there. So this is called as the function call. So when the values are there available with main function, what the main function is doing is, instead of adding the values by itself, what we call it here is that the main function is actually calling another function. What is the function that is being called? Add. While calling add, what are we sending as arguments? We are sending a and b. And what are a and b? A and b are two integer variables having the values 3 and 6. So what happens at this point of time is that the control jumps to that function. That's what we call it. That is, before this statement is executed, the control actually jumps to the function which is being called. And as it jumps, the communication takes place. And what do you mean by the communication? It's very simple. You are actually sending two values. A, 3 value is there. In B, we have value 6. So the value in A gets copied into X here. So the value of 3. And as the control jumps there, the value in B also gets copied into Y. So when this function is called, the control jumps there. As it jumps, the value in A and B variables, they get copied into the corresponding variables X and Y, and the body of the function, as we call it, begins to get executed. As you can very easily see, as the control enters this function, a temporary variable is declared as sum. Sum is now set is equal to A plus B. So, sorry, not A plus B, it should have been X and Y, because this function does not know about A and B. In this function, only the names that we can use are the names that have been declared either in the arguments or in the body of the function. So X plus Y. So X has taken the value of 3, Y has taken the value of 6. 3 plus 6 will be added. The value gets set into sum, which is 9. Now here, finally you can see that the function is actually returning the value in sum. So what is the value in sum now? 9. So what does the return mechanism do here? That's what you have to understand very clearly. So what has happened so far? Main function has started. It has taken the two values, and when it has come to this line, a function call was made. As the function call was made with the variables A and B, the values in A and B were copied into this function. The control jumped there, so it begins to execute this. And when it finally encounters this return statement, the value in sum, this variable right now is 9. It contains a value equal to 9. So that value is returned back to where it came from. That is, the control went into that function because of the function call. So once it finishes, the control comes back, and whatever value that has been returned will be replacing the function call, meaning this function call add A comma B will now be replaced by whatever value that has been returned. In this particular case, the value happens to be 9. So then we can evaluate this expression. The expression is 3 times add A comma B. Add A comma B has been evaluated to the value 9. So 3 times 9 will be calculated. The value will be set in C. And we come down to the next statement, then we are printing the value in C, and where you can very easily see that the value of 27 is going to be printed as output on the screen. So we have simply, what we have done here is, instead of putting the code in the main function itself, we have just taken out some part of the code and we wrote a function for that. And whenever we wanted to add two values, we are actually calling the function. So in reality, the function may not be so simple. Usually we have some substantial amount of code in every function. That is the reason why we actually design it as a function, as a separate function, and call it whenever it is necessary. So usually we try to write a function for the specific tasks which need to be frequently called, or well-defined tasks which need to be called in several places in the program. So instead of writing the code so many different times in the same program, whenever we need to carry out that particular task, we simply call that particular function. So let us try to summarize this idea again. So first of all, whenever you think of a function, we need to think of what is the function doing. So according to that, you give an appropriate name. And then next important thing is, does it receive anything? Does it require any inputs in order to work and carry out the task that it is supposed to carry out? Yes, in this particular case, it needs to receive two values. So how do you specify that? You can see here, these are the arguments. So in this particular case, we can see that the function actually requires two integer values as inputs. And then you have to also think about, fine, it receives two integer values. what does it do, and does it return any value? Yes, in this particular case it returns a value. And what is the type of the value? In this particular case, you can again see that the value that is being returned back to the caller is of type integer. You can see here sum has been declared as an integer, and that's exactly what we mean to specify here. So when you look at a function header, as we call it here, this is the prototype, this is the header, this total thing together is known as the function body. So inside the braces here, we put whatever code that is required for the function to carry out the task that has been set aside for the function. It could be 2 lines, it could be 2000 lines, the size could be anything. So that is not there is no restraint or constraint on the number of lines that you can write in a function. So no matter how big or small the function is, the behavior is still the same. So we have to again come back and let us try to understand how this has been split up. So now we can see that instead of one function, we have 2 functions. The particular function we have in our hand, we have designed it in such a way that it simply receives 2 values, adds the 2 values, and sends back the sum. And you can see in the main function how we are making use of the function that has been written. So in this particular function, what we can see here is the main function begins execution. It has 2 variables which it reads from the user, and those 2 values which has received from the user, it is sending to another function which has been called as add. That is what is happening here. So once this function is called, the values are being sent, because the function has to receive the values. So it has to receive the values, somebody has to send the values. So who is sending the values here? The main function is sending the values. So in order to send the values, the main function first, it has to have the values. So we have designed the program in such a way that main functions receive the values from the user, it puts them in its corresponding variables, and then when it calls the values, what actually happens here is, you can think of the 2 variables x and y like this, and when the function call is made like that, the values in these 2 variables, they get copied into the corresponding variables there. In this particular example, the variable gets 3, the y variable gets 6, those 2 values are added. There is another variable called sum, it will have a value of 9, and that value is being returned back to the place where the function call has been made. So we say that the function call is replaced by what? By the value that has been returned by the function call. So in this particular expression here, the function call will be replaced by the integer value which is 9, which has been sent back by the function, and that will be used in an expression that 9 is now multiplied by 3, and it finishes the program. So the control starts in the main function, comes up to this function call, goes to the function, finishes the function, comes back to the function call again, and then this expression is finished, then it goes back. So you can see that when a function call is made, what we call as a jump of control takes place. So main function you begin with, until the function call it comes there. When a function call is made, the control jumps there. It could perhaps copy some variables as has occurred here. Once the values are copied, the function works with them, finds out a required value, and sends back the value, and the value is received in the same place where the function call has been made, and the control resumes or proceeds from that point, and then goes on like that. So in any given program, you can make any number of function calls, but what we have to very clearly understand is the fact that whenever a function call is made, we can identify a function call with the parenthesis. Printf is a function. We have never mentioned that before, but printf is actually a user, it's a library function. Scanf is a library function, whereas add is what we call as a user defined function, because we are writing the function ourselves, as against printf and scanf, which are already written by somebody else. They are available to us. They are provided in what we call as a library, and the library contains usually functions which are very frequently used. For example, if you take a math library, generally we need to use cosine, sine, tan, so on and so forth, and square root. These kinds of functions are usually required whenever you are writing some mathematical applications. So people have recognized that, and they have already provided us with all those frequently used functions. So all the functions that are available to us ready-made are usually known as library functions, and the functions that we write for our own purposes, they are known as user-defined functions. Otherwise, there is no difference between either a library function or a user-defined functions. Both have to obey the same rules. They have to follow, or they will have the same mechanism, only whether it is already available or we are writing ourselves. Based on that, we just call them either library functions or as user-defined functions. So some more notation, let us try to summarize here. This is the function prototype, where we give the name of the function in brackets, what we call as arguments. So they must be given. This is the syntax. The prototype must end with a semicolon, and what we put here is known as the return type. This is the function call here, and A and B here in this particular case, they are referred to as actual arguments. So what goes in here can be called as actual args or arguments, and the corresponding arguments in the function definition, they are known as formal arguments, sometimes also known as dummy. More informally, they are known as dummy arguments, but usually we call them as formal arguments. They receive the values from the actual arguments when the function call is made. Until that point of time, they don't have any values. If you send some other values, they receive those values and work with them. So it all depends on what values are being sent from the caller. In this particular case, the caller is the main function. It is calling the add function with the values. Those values get copied, works with them, sends back a value. The value that is sent back is used in an expression like that, and the function continues. So these are the basic components or elements in a function mechanism. So if you can understand how to actually, given a situation, recognize a well-defined task, and in order to carry out the task, what are the inputs required, and upon completion of the task, what will the function send back. First, if you can think about that, establish that, it becomes very easy to write a function. So the same thing, same thinking, let us continue with one more simple example, so that we can understand the mechanism of functions better. Now let us try to take one more example, the familiar perfect number example. Perfect number is nothing but a number for which the summation of its factors excluding itself will be equal to the number itself. So if a given, for the example is 6, if you can take 6, its factors are 1, 2 and 3, 6 is not included. So 1 plus 2 plus 3, that is equal to 6. So in such cases, for a number for which the summation of the factors is equal to the number itself, we call it as a perfect number. Now let us try to write a function for that. First of all, whenever we have to write a function, we need to think of three things importantly. So let us try to establish that first. First, easiest part is what should be the name of the function. So let us call it as perfect. Next question is, when you call this function, should we need to send this any value, or in other words, should the function receive any value? Yes. So what is the behavior of the function? Given a value, the function should answer either the given number is perfect or not. For example, if 6 is given to the number, it must say yes, it is a perfect number. If 5 is given to the function as input, it must say no, it is not a perfect number. So how should be the behavior? So we named it as perfect, and we are saying given. So it must receive a value. How many values it should receive? It just receives one single value which it has to evaluate. So what is the type of the value? Let us say it is simply a integer, and upon receiving that value, it will calculate the summation of the factors and return something back. That also is part of the design. So you can say that usually functions communicate with each other because it can't say yes or no. They deal with numbers. The usual practice is they send back integers. If 0 is sent back, it is answer is no, that is false. And if any other value is sent back, the answer is usually yes. So we generally make use of 0 and 1 as answer no or yes. So if the function wants to say yes, it is a perfect number, then it should return a value of 1. If the function wants to say no, it is not a perfect number, it will return a value of 0. So whether it is 0 or 1, the type of the value is int. So that creates the prototype of the function. So as a programmer, when we think about a function, we have to think about three things mainly. What should I name it? Easily answered. Then should this function be given any values to work with? If so, how many of them? What are the types of those arguments? There can be any number of arguments, any types, mixed types could be there, but that has to be thought of by the programmer before he begins to write the program. So in this particular case, I have thought about the function perfect. I have established that okay, my function is going to be like this. I am going to name it as perfect. I will give it one value, an integer value, and it will send me back one more integer value, and I know that returned value is only going to be either 0 or 1, and I know what is the meaning of the return value of 0, and I know the return value, the meaning of the return value 1. So both cases, this is the understanding first you have to begin with before you write any piece of code. So that is also in a way helps you. The prototype is first thing that you have to think about. So that in essence answers many of the most important philosophical questions about a function. So once we having decided that, let us go ahead and write the function and the program. Now let us try to look at the program which has been divided into two functions. One is the main function, another one is the perfect function. Please notice that after you can't define one function inside the other function. So nesting of functions is not allowed in C. That is, you can't put the body of one function inside the body of another function. You can call them, but you can't put the body inside. What I mean by that is, you see the main function is beginning here and ending here, and after that another function is written. So let us now again look at the execution. Let us trace the program. Again you can see that the prototype of the function I am going to use at a later stage is given here in the beginning itself. Execution begins here. Two variables have been declared. You are asking for a value, and the value is asked. The user will supply. So n is declared in the main function, so I will write it on this side. Assume that the value is 6. And once the control comes here to this line, it encounters the function call. As we already know, whenever a function call is made, the control jumps to that function. The control jumps to that function. That is, before a value can be put inside result, it has to be evaluated. This function has to be executed. How does that happen? The control simply jumps. So while jumping, the arguments get copied. For example, the value in n is actually 6 right now. So the value in n variable here gets copied into n here. These two n's are different from each other. Any name can be used here. So the value in n now gets copied into, there is one more n here which gets the value of 6. I and sum are declared inside this function. So once the control jumps here, it has to execute all these statements. From main it comes up to this point, jumps here. While jumping, values are copied, and this code is executed. I and sum are declared here. We know the code or logic for finding out the perfect number. We go from 1 to one number less than n, and each one of those i's is tested. The code has to be actually, it has to be tested. If n mod I is equal to 0, then we say sum is equal to sum plus I. So each one of the i's is tested whether it is a factor of n, and if it happens to be a factor, we add it to the sum. So this goes on with all the i's starting from 1 to 1 less than n, and the sum of all the factors is available once the loop is over. So after the loop, you can see here we are testing. So if the sum that we have found out happens to be equal to n, we are returning value 1. And if the sum happens to be not equal to n, that is, we are returning a value of 0. So in this particular case, we know that when this code works with 6, the sum will also be equal to 6. So this test is true. So if that test is true, the value when return is encountered, 1 is returned. So this statement, return statement, causes the control to come back to this function call. And as we have already mentioned before, the function call here, which is perfect in brackets n, will be replaced by the value that is returned, which in this case is equal to 1. So the value 1 gets copied into result, and the control will proceed to the next statement here in the main function. So the control in the main function comes on to this point. Upon encountering the function call, control jumps there, receives some values, works with the values, and then using the return mechanism, a value is being sent back. That value comes back to this function, main function again. So I draw the line here and see that control is jumping back and forth. It's going there, executing, coming back here. It comes here. The value that is returned back using the return mechanism will replace the function call here, which in this case is 1. That gets copied into result, and the control will resume in the main function from this point onward. So it comes here. In this particular case, this test is carried out. As we already know, this test is true. If that is so, main function will now print perfect on the screen. So if any other value has been sent, for example, the user has input a value of 5. Now we know what happens. Comes here, n is 5, 5 gets copied into n. We will know once this code is executed, the sum is definitely not equal to 5, because from 1 to 5, 5 is actually a what you call a prime number. So only 1 is the product or a factor. So the sum would be 1, definitely not equal to 5. So in this case, this will be false. In that case, 0 will be returned. So using this return statement, value will come back here, and now it is not equal to 1, but it is equal to 0. In this particular case, 0 is copied into result. Main function checks whether it has received 1 or 0, because you are asking a question, you are handing down the value to the perfect function, and you are receiving the answer. So depending on the answer received, 1 or 0, it has to examine that. So depending on that, it will decide to do some work. So in this particular case, the work is very simple. It just receives the value, examines that value like this, is if result is equal to 1, perfect. Otherwise, it will simply print it as it is not perfect. So this is what the mechanism is. So you have to very carefully be able to think about how functions work. So whenever we think about a function, we have just discussed, to summarize, we have to think about what is it designed for. First thing, what is its task? What is its well-defined task? Okay, it is supposed to tell whether a given number is perfect or not. Given a value, it is supposed to return the cosine of that angle. Given an angle, it is supposed to return the sine of the angle. Given two values, it should return the sum of those two values. So like that, first establish what the function is supposed to do. Then think of what should I name it, how many inputs does it require, and what are the types of those inputs. And upon finishing its job, what is the type of the value that it is going to return back to the caller. So that actually completes your thinking about the function, which can be abstractly put down in this fashion, which we call as the function prototype. And once that is done, of course, this is how you write the function. This is called the function body. The header is there, which should exactly match with the function prototype. And you see the braces, open brace and close brace, just like we use for the main function. And upon finishing that, it comes. So the calling mechanism, whenever the function is called, it must be understood very clearly that the control jumps to that particular function. Once it is finished, it comes back. So this is how we should think about any function when you are asked to write a function in order to carry out a task. And once you begin to do that, I think you can very easily decompose a given problem into functions. Thank you.